This will be Unit 6 in Forensic Science. We're going to look at analyzing glass and paint as trace evidence. Our objectives for this unit are to describe instrumental analysis of trace evidence, such as microscopy and spectrometry, to demonstrate how to process trace evidence, such as glass and paint, to compare and contrast the composition of various types of glass, to determine the direction of a projectile by examining glass fractures, to define refractive index and explain how it is used in forensic glass analysis, and to describe various examinations performed in forensic paint analysis. In this first video, we're going to look at the composition of glass. So glass evidence is a type of trace evidence that can help establish the events of the crime. And while it can be used in a variety of cases, it is most often found on the scene of accidents and break-ins. So your typical glass is created by melting down sand, or also known as silica or silicon dioxide. Then they add lime, which is calcium oxide, and sodium oxide, and this creates what's known as soda-lime glass, which is your most basic form of glass. They use it in making jars, windows, lamps, and food or beverage containers. Another type of glass you may see is crystal or leaded glass, and they make this by substituting lead oxide instead of the calcium oxide. And that's the kind of sparkly glass that you see with the cut crystal glassware or stemware and crystal jewelry. Another type of glass that you may come across is borosilicate glass. They add compounds to increase the stability of the glass, especially under high temperatures, and this would be typical for baking dishes, industrial equipment, lighting, and lab equipment like what you would run across in a chemistry lab or even in a forensics laboratory. You would see borosilicate glass. Another thing they may do to the glass is they may temper the glass, which increases the strength of the glass by compressing the surface and expanding it inside of layers so that it doesn't break as easily. And you see those used indoors, in athletic facilities where they have like all glass windows, phone screens, and vehicle windows. And then there's laminated glass where they sandwich a polymer in between the layers of the glass so that if the glass breaks, it holds together in one sheet. And so you see that in vehicle windshields. So glass has a lot of different physical properties that can be analyzed and matched to match question samples to with known samples. One is the density, so the mass divided by volume. So the different glasses have different densities. So if you measure the glass's density, you can use it as a comparison analysis. So soda lime glass is typically 2.5 grams per milliliter. Pyrex, which is a type of borosilicate glass, is like 2.27. Tempered glass is around 2.98. Also, the thickness of the glass can tell you its origin because the different applications of glass require the different thicknesses. So for example, window glass is about 1/8 of an inch thick, which is 3 millimeters. And door glass is 3/4 of an inch thick, so 19 millimeters. So if you measure the thickness of the glass, it can give you an idea of where it came from. Glass is an amorphous solid, which means it's solid, but it doesn't act entirely like a normal solid. The molecular structure of the glass is closer to a liquid than a typical crystalline solids. Instead of being locked in place, the molecules can actually stretch and compress slightly without breaking. And in fact, in the older glass panes, what you would have happen, like with antique glass, you would see that from it hanging in the frame, that the bottom part of the glass would actually be thicker than the top part because those molecules would slide down with gravity. So also because of this amorphous structure, when glass breaks, it fractures into shards. And the fracture pattern can provide information about how the break occurred. You'll see two types of cracks in a glass fracture. The first is a radial crack and begins at the site of impact and radiates outward based on the amount of force used to break the glass. And the radial cracks will always form on the side of the glass opposite the force. Then the second break is a concentric fracture, which basically connects the radial fractures like a wheel, and they form on the side of the glass the force was on because the tension and compression of the ripples of the force will cause those fractures. So when we're analyzing glass, we have to piece together the glass fragments to find the fracture pattern. And what they're looking for is you'll look underneath a microscope for rib marks on the side of the radial crack in the glass. You have to find the radial crack, and you have to look at the side, and you'll see these rib marks, which are these bent lines, and they're going to form perpendicular opposite the side of the force. So with these rib marks, they're almost perpendicular on this side of the glass, which means that the force was applied from the other side. Sorry, I'm losing my mind.